Problem 28. Here we have a cylinder initially in rotation about the axis, vertical axis, with initial angular speed omega initial. And we have a second cylinder was at rest. Okay, so this one is the initial state. We drop the second cylinder on the first cylinder, we get the final state of the system. Because the interaction between these two objects, the system will move with a single angular speed omega final. As you see here, omega initial vector is up and omega final vector is up. You know, you can precise the direction of omega by using your right hand rule. Okay. Now, I ask you to find omega final. You know, if we have the summation of tau external equals to 0, in this case, we have an isolated system and we have a conservation of angular momentum. Here we have I initial and we have I1 and I2, and here we have I1 doesn't change and we have I2 added to the system. So we can say initially we have initial I is I1 times omega initial, and the second cylinder was at rest, equals to the final state. We have E final, which is equal to the summation of E1 plus E2 times omega final. I ask you to find omega final, which is equal to I1 divided by I1 plus I2 omega initial. This is the value of the final part B. Show that the kinetic energy of the system decreases in this interaction and calculate the ratio of the final to the initial rotational energy. So we have to show that the kinetic energy final is less than the kinetic energy initial. Okay, let's calculate each one. Kinetic energy initial equals to, here we have only a rotational motion, equals to I1 over 2 omega initial square plus 0. And kinetic final equals to here we have this one and this one. We have I1 plus I2 divided by 2. And here we have the same angular speed omega square. Here we can calculate the ratio between the kinetic final divided by kinetic initial. We get kinetic final, we have I1 plus I2 divided by 2 omega final square. Kinetic initial equals to I1 over 2 omega initial square. And you know, we calculated the relation between omega final and omega initial, which is equal to I1 divided by I1 plus I2. We can substitute the value here. We can eliminate 2 and 2. Here we get I1 plus I2 divided by I1, and we can here we have I initial square. We substitute the value of omega final square. We get I1 square omega initial square divided by I1 plus I2 square. Okay, we can eliminate this one and this one, square with this one, square with this one. We get finally kinetic final divided by kinetic initial, which is equal to I1 divided by I1 plus I2. You know, this value is less than 1. Okay, you know here. So we can say kinetic final divided by kinetic initial is less than 1. So kinetic final less than kinetic initial. Okay.